Two or more methods can share the same name as long as their method signatures are not exactly the same. This is known as method overloading. To review, a method signature consists of the method name and the method parameters. Note that the return type of a method or any modifiers that may be used, such as private, public, or protected, are not considered part of the method signature. So looking at this method here that takes 3 integers as parameters and returns the sum of the 3 integers, the method signature would simply look like this. As an example of method overloading, we can create another method called addInts, but instead of requiring 3 integers as parameters, we can instead only require 2 integers. That method would look like this, and the method signature would look like this. Putting the two method signatures side by side, it is easy to see that the method signatures are not exactly the same. The first method signature requires 3 integers as parameters, whereas the second method signature requires 2 integers as parameters. While the number of parameters these methods require is different, they both share the same name of addInts. Essentially, any 2 or more methods can share the same name as long as they differ in the number of parameters, the type of parameters, or the order in which the parameters are listed in the formal parameter list. The example we just covered worked because the number of parameters in the formal parameter list were different. The first had 3 parameters and the second had 2 parameters. Here's an example of method overloading that works because the parameters used in the formal parameter list are of different types, with the first containing an integer as a parameter and the second containing a string as a parameter. And here's an example of method overloading that works because the parameters used in the formal parameter list are ordered differently, with the first method having a string as the first parameter and an int as a second parameter, and the second method having an int as the first parameter and a string as the second. Notice that we could have made the second method to print name and ID num as well, like such. In this case, printinfo would still be an accepted overloaded method, since the order in which the parameters are listed is different, with the integer variable being first and the string variable coming second, the opposite order of the parameters of the first method. I only changed the name of the formal parameters to make the example just a little more interesting. Now you may be wondering why you would ever want to use method overloading in your program. And the answer to that is sometimes you may need a method to have very similar functionality as another method, and while you could technically just give the similar method another name, utilizing method overloading is one more aspect of writing code that adds to the elegance of a program. One example that makes it clear why method overloading is useful is in writing constructors. Say we are creating a class called person. Some attributes of this class may be name, age, height, social security number, and address. A constructor of this class could look something like this. This constructor would work fine if each attribute of this person object was known in the creation or instantiation of it. But what if one of these attributes are not known, or simply not necessary? While one program may store and supply the required data to instantiate a person object using this constructor, another program may only store name and age data and therefore only be capable of providing that data as parameters. And if we try to use this constructor only providing 2 variables as parameters, we would get an error, as the compiler would not recognize which method is being invoked as the method signatures would not match. Therefore, we would need to utilize method overloading and write a constructor for the instance in which only a name and an age would be passed as parameters to create a person object from the person class. That constructor would look like this. Once again, we could create any number of variations or overload this method any number of times in order to maximize usability of the person class. As long as the parameter list of the overloaded method differs in number of parameters used, types of parameters used, or order in which the parameters are listed, the compiler will successfully determine which method is being called based on its method signature in the invocation of it.